Hey everyone, welcome to day 30. It's been pretty much a month and it's already the 1st of April, and today we're going to be talking about Kubernetes Pods. First of all, before we dive into this, there were already a few things that you should know. There were some prerequisites such as the basics of Kubernetes architecture and also being able to set up your own. So I'll show you guys how to set it up tomorrow, like how to set up your own Kubernetes environment on the local machine. But for now, let's just dive straight into pods. So first of all, what is a pod? Well, a pod is the smallest deployable unit in Kubernetes. That's like kind of the definition, but what it does is you can think of it as like a wrapper, I guess. Wraps around one or more containers and allows those containers to work together. So pretty much it provides a shared environment for containers, right? That means that they share networking, storage volumes, and resources. So networking such as localhost, they can communicate through localhost, which makes it a lot easier for them to work together. And they share storage, so containers within the pod can access those like common data. And they also share resources like CPU and memory, which allows them to run more efficiently. So that's why pods are used to run applications within a Kubernetes cluster, as they allow for scalability and management. So how do we actually scale with pods? And how does pods help with scaling? So instead of adding more containers inside a single pod, Kubernetes scales your applications by creating more pods. And you can scale your applications in two ways. First of all, you can scale up or scale down. So scaling up will add more pods. Scaling down will remove unnecessary pods to reduce load. And Kubernetes also has the ability to distribute pods across multiple nodes for load balancing. What this means is that as demand increases or decreases, Kubernetes automatically scales your application based on the number of pods running. So you don't have to keep track of that all the time. That's one of the big benefits of Kubernetes. Next we got multi-container pods. So what happens if your application needs more than one container? A pod can contain multiple containers, right? And these containers can work together, right? This is where multi-container pods come in. Some common use cases for multi-container pods include main application and helper container, for example a web server with a logging container. There's also processing pipelines, which is one container fetches data and another processes it. And then lastly, we've got sidecar containers, which adds functionality to the main container, like logging, monitoring, or data backup. And here's an example of a multi-container pod, what it will look like. So as you can see here, container, it's like a list. We have the first container and then the second container. So both containers in the pod share the same network, storage, and they start and stop together when the pod is created or deleted. So next, deploying pods with Docker and Kubernetes. So how does this all work in practice? What are the commands and such? So before you deploy in Kubernetes, you can run containers manually with Docker, right? For example, you can use the following command: docker run detach with the name my app, port 808080, and then the name. So that's how you deploy it manually with Docker. And to scale manually with Docker, once again, just spam docker run. And if you require a helper Docker, you can manually link them like so with link. But Kubernetes, as you can see, this is quite complicated. Kubernetes will simplify this process. So once again, I'm showing you how Kubernetes as an orchestration tool adds on to Docker and makes it a lot more useful. So yeah, with Kubernetes, you don't need to worry about manually managing these links here or scaling, right? You can define all this in a single pod configuration. And then Kubernetes will do all the work for you, which is really nice. So how do we deploy on Kubernetes? So we use the kube control command line tool, right? So creating a pod, kube control run. Let's say you want to run nginx, and then the parameter image equals nginx. And this command will pretty much tell Kubernetes to create a pod running the nginx container. And then Kubernetes will pull the image from Docker Hub or any other registry that you specify. And after you get it running, you can check the status by doing kube control get pods. And here's an example, like at first your pod might be in a container creating state like so. This is just an example, so as you can see it's not ready, but after a few seconds it will say 1 out of 1, so it is ready. Obviously this is just showing you, I haven't actually done any hands-on, I haven't shown you any hands-on. I'll plan on doing that tomorrow. At this stage, yeah, your Nginx server is running in this cluster, however it's not accessible externally, as Kubernetes requires additional configuration for network and services. So to get more detail out of your pod, you can run the command kubecontrol describe pod nginx. This will give you a lot more details, and later on I'll demonstrate that. And then delete a pod, simply kubecontrol delete pod nginx. So next, how do we scale with deployment in Kubernetes? So instead of manually adding or removing, Kubernetes will allow you to scale the deployment dynamically. So what that means is, for example, if you want to scale your application to 5 pods, just following command kubecontrol scale deployment and name of your app, and then use the parameters replicas equals 5, and once again use the kubecontrol get to check how many pods there are. So a brief summary of everything of pods. So pretty much pods they're the smallest deployable units in Kubernetes, and they help manage one or more containers. And scaling in Kubernetes involves creating more pods instead of adding more containers to a single pod, or getting rid of redundant ones. And then multi-container pods allow different containers to work together, sharing resources like network and storage and memory. And then Kubernetes overall just simplifies deployment and scaling, so you don't need to manually manage all the containers. And here's just a brief table that I made. Single container versus multi-container pods. So that's all for today. I recognize that I should probably add a lot more images that can help convey these ideas, maybe make it easier to remember. So starting tomorrow, a lot more. It's been a month, right? So starting tomorrow, there'll be definitely improvements to these videos. I'll try to add more images. I'll show more hands-on with my own examples instead of just taking these from the lab straight away. And yeah, look forward to the second month. But I digress. Thanks for watching. See you guys tomorrow.